In this video, we will discuss some bitwise manipulation techniques which are useful for solving interview questions related to bitwise operators. In order to understand these techniques, we need to know some terminology. So let's discuss that first. Set a bit. This means to set a bit value to 1. Clear a bit. This means to set a bit value to 0. Toggle a bit. This means to change the value of a bit from 0 to 1 or from 1 to 0. Now we know the terminology. Let us look at the bitwise manipulation techniques. The first technique is about setting a bit value at a given position. To state the problem formally, given a number n, set the kth bit in the binary representation of n. I'm counting the bits from the right side and assuming that the rightmost bit is the 0th bit. So the problem is to convert the kth bit to 1 and leave the rest of the bits unchanged. In order to achieve this, we will take 1 and left shift it by k bits. From a previous video, we know that the binary representation of 1 as a 32-bit binary number is 1 prefixed by 31 zeros. So 1 left shifted k times would give us this number. Now applying bitwise OR on both the numbers would give us a new number in which the kth bit would be 1 and rest all the bits would be the same as in the original number. So the expression n or 1 left shifted k times is used to set the kth bit in the binary representation of the number. Pause the video here for a second and think why this expression works. Let me give you a hint. It has something to do with how bitwise OR works. If you are unable to figure it out, then leave a comment below or ping me on Instagram. Let's move on to the second technique, which is about clearing a bit at a given position. Just as before, we have a number n and we have to clear the kth bit from the right. You may want to pause the video here and try to figure it out yourself. In order to achieve this, we will take bitwise NOT of 1 left shifted k times. We have already seen 1 left shifted k expression in the last technique. So applying bitwise NOT on that expression gives us this number. Now we will take bitwise AND of the original number and the expression NOT of 1 left shifted k times. This would give us a new number in which the kth bit would be clear and rest all the bits would be the same as in the original number. So the expression AND and NOT of 1 left shifted k clears the bit at the kth position. Now we know two techniques. Let us see how we will code these two techniques. Here I will give code in Java and Python, two of my favorite languages. SetBit is a method that takes two parameters, a number n and position k. SetBit will set the bit at the position k in the binary representation of the number n. Similarly, clearbit will clear the bit at the position k in the binary representation of the number n. Let's move on to the third technique, that is to check if the kth bit is set or not. Again, we will start with the number n in which we want to check if the kth bit from the right is set or not. Just pause the video here and try to figure this one out on your own. I'll give you a hint here. In both the previous techniques, we started by modifying the binary representation of number 1 by applying bitwise operations on it and then used it at our advantage. Let me give you the expression for this technique and you must try it on the number n we have here. So the expression to check if a bit is set or not is n and 1 left shifted k times greater than 0. If this expression is true, then the bit was 1, else it would be 0. Now we have three techniques at our disposal. We can combine them to implement functionality to toggle a bit at a given position. So we will directly jump to the code. Here we are just checking if a bit is already set or not. If the bit is already set, then we are clearing it, else we are setting it. Now let's see the last two bitwise operator related techniques, that is division by 2 and multiplication by 2. We have already seen these two in our last video. We do a right shift for integer division by 2 and we do a left shift for multiplication by 2. Using bit shifting for division by 2 and multiplication by 2 is much faster than using division and multiplication arithmetic operators. This trick comes in very handy when solving some programming questions. So to summarize, in this video, we had a look at some bitwise manipulation techniques which are useful in some scenarios. From the next video, we'll start solving some interview questions related to bitwise techniques. If you have any doubts, then leave them in the comments below or ping me on my Instagram handle, that is 10xcoder. See you in the next video.